discussion. Again, moderator is by Amy herself. And without further ado, I'm just going to hand over the floor to her. Amy, all yours. Thank you.
Oh, great. Thank you. Yeah, now we're going to have another batch, but this is, I'll just call it deeper science, right? And, I think these guys have an interesting journey, especially really, really interesting tech and different approach to various aspects that they're working on. And I'm just going to kind of get right to it. So the first one I'm going to have go is Alex from Power to Hydrogen. And we know him from the labs, Enro Labs, and we work there. Like I said, the U.S. has got a lot of activity happening. Shell Game Changer, linked to NASA. So I think it's interesting on some of these themes. You see a lot of linkage to space technology, right, that we haven't seen before. So let me first pass the floor to Alex, and you can tell us all about Power to Hydrogen. Thank you.
Okay, I'm going to assume it is. Right, so as Amy said, my name is Alex Zorniger. I'm presenting from Power to Hydrogen. So at Power to Hydrogen, we have a patent-protected technology that enables us to create low-cost green hydrogen. And so to start out, a little bit of the big picture of hydrogen. It gets a lot of attention in the press and things like that. A lot of people are talking about it. One of the biggest areas they're talking about and some of the excitement is in the clean transportation space. So there's definitely use cases in clean transportation, specifically in any sort of commercial vehicles that have long haul trucking, things like that, where they need to be able to refuel quickly. But there's also some really exciting applications. Right now, there's a massive market for hydrogen in industrial hydrogen. And that hydrogen is currently produced from natural gas, so it emits greenhouse gas emissions in that process. So there's already a very large market for the hydrogen that could be potentially green hydrogen. There's also a big use case in energy storage. The opportunity to produce hydrogen and then reconvert it back into electricity. You can store massive amounts of energy in this way. For long duration energy storage, anytime you need to have very high reliability with all of the new renewables we have, whether it's the sun isn't shining or the wind isn't blowing or there's natural disasters, hydrogen shows really great opportunity for those energy storage applications. Now, there's been multiple decades talking about hydrogen. The early 2000s, people were really excited about hydrogen, but it never came to fruition. And so we're talking about hydrogen again. Is it a fool's errand? Is hydrogen actually going to come through this time? And at Power Hydrogen, we really believe it is. And we believe this time is different significantly because the opportunity of significant deployments of low-cost renewable energy. So 60 to 80% of the cost of hydrogen is determined by the electricity price. So in the 2000s, when you had electricity produced from coal and natural gas and oil, the marginal cost of those fuels was just too high to make hydrogen competitive. Now, when you have situations where different countries are producing, having to curtail wind and solar in certain periods, you can get extremely low cost electricity. And this enables the production of cost-effective, green, clean hydrogen. Now, the electricity prices have reduced, which has created an opportunity for clean and green hydrogen, but there's still challenges along the way. To produce clean hydrogen, you need to use electrolysis, so applying electricity to water to split hydrogen from oxygen. Currently, the main mode of electrolysis is alkaline electrolysis. So this technology was developed maybe 100 years ago. It's very mature at this point. They're able to produce cost-effective hydrogen. It's a lower system cost. The problem is in the response time. So wind loads are always shifting, the clouds are coming, and solar's not always producing at maximum capacity. So electrolysis technologies need very quick response times to be able to adapt to the changing loads. Alkaline electrolysis systems do not do well in these systems. Recently, scientists have developed another technology called Pem Electrolysis, where this technology is able to switch very quickly between off and on and handle dynamic loads, but it's extremely expensive right now. So there's still a challenge to produce cost-effective hydrogen from these wind and solar sources. And then all of these down here are still in the lab right now. There's a lot of potential for high-efficiency electrolysis, but they haven't figured out the way to get it to the market in a cost-effective way. So at Power to Hydrogen, what we do is we take a different approach. We're using something called an anion exchange membrane, or AEM technology. This is some of the newer electrolysis technology. And what this allows us to do is to get that fast twitching and dynamic ability to adapt to dynamic loads that you see with the PEM system for a lower cost price. So this anion exchange membrane, we have a patented technology on our cell design. This allows us to have reversible operation, so we can produce hydrogen as well as having that energy storage reversible component for backup power. We're also able to produce hydrogen up to 250 bar without the need for a compressor. So this drastically reduces the system cost if you're using the hydrogen for a high pressure need like a vehicle refueling, because they need the pressure at 350 or 700 bar. Our AM technology also allows us to use lower cost materials. In certain systems, there's the use of extremely rare iridium. There's also the need for a lot of platinum and titanium. Our system reduces the need for many of those expensive materials. So we're able to get the system cost down. As I said before, we're able to handle those dynamic loads and fast switching times with this patented cell design. We also have trade secret protected catalysts, which enable a lot of this capability. So we've got the patent as well as the trade secrets to enable this performance. We're also able to capture the pressurized oxygen, which has certain use cases in different areas, whether it's an industrial process that needs hydrogen and oxygen, like steel making or like syn fuels, or potentially in the reversibility mode. So again, that value proposition is reversible operation for our system, a lower cost of equipment, and then the high pressure operation for specific use cases like vehicle refueling. And so to show you a little bit more about those costs, so the United States Department of Energy set the goal for below $500 per kilowatt for an electrolyzer. That's what they predicted that systems need to be to make them cost effective with either gray hydrogen, so dirty hydrogen, or certain fuels. And so we believe once we scale up technology or scale up production, we can get below that $500 per kilowatt and beat the very popular PEM systems today, and just be above 400 kilowatts or $400 per kilowatt. What this lower system cost does is it allows us to get below $2 per kilogram, which is another one of the Department of Energy targets, and one of the targets of governments across the globe. And so at all levels, because we have this lower system cost and higher efficiencies, because we can go to higher pressure, we can beat the cost by PEM electrolyzers and get below $2 per kilogram. And then because our system can be used for energy storage, it can also have a higher utilization, so you can get more ROI for the technology. You can either use it to produce hydrogen to generate revenue through that, or you can have the energy storage where you're producing backup power. Some people will currently be pairing a PEM electrolyzer with a diesel generator. Our system, you can do that all in one. So our team has a variety of scientists that have been working on fuel cells for multiple decades, led by Dr. Paul Matter, who has a PhD in chemical engineering. He's been working on a variety of different fuel cell types, has been in the industry for a while and is an industry leader. And then a variety of different team members bring a lot of experience. And so for our validating partners, we've talked a lot about the promise of the technology, but who's really engaged, who's committed to it? So we have a project with Shell. They're funding the development for that hydrogen production that's compatible with renewable energy, just like we talked about. NASA is really excited about our system for the energy storage component, so they're also funding development. We have a local transportation organization that has hydrogen buses, and they've contracted with us to develop our system for their hydrogen refueling. They're also going to use our system for backup power to increase the return on investment. And then there's one customer that we cannot name, but they're using our hydrogen for bulk, or our technology for bulk hydrogen production for their chemical process. And they will also use the oxygen as well. So our system has a lot of great opportunities specifically for low cost hydrogen. But if you really want the best opportunity where our system will provide the most value, it's either in high pressure applications such as vehicle refueling stations. It's any situation where you're pairing the hydrogen electrolysis with renewable energy. Anytime you need to store energy, backup power, peak shaving, things like that, or an industrial process that needs hydrogen or oxygen, we can capture both of those at high purity. And so for the stage of our company, we just finished our seed funding round. We are finishing our first commercial prototype for a vehicle refueling station. And we believe we'll have multi-megawatt installations by 2023 of our products. So thank you. That's what I have for you today. Amy, what can I answer for the audience?
Oh, that's really good. Yeah, I'm gonna pull you guys back in after you present, and then we can talk about the things that you're working on. But tell me real quick, what is your biggest challenge, you think, where you guys are at now? I mean, you kind of had the support of Shell Game Changer.
Yeah.
But you've got interest from industry. You've raised your kind of pre-seed, kind of seed round. What do you think is your next biggest challenge that you guys got to take on here?
Yeah, I think the biggest challenge, so obviously we're working on some supply chain challenges to build up that technology and identify any potential supply chain issues that might be a challenge to us. We're working on those. And I think once we develop, or once we finish the solution to those challenges, it's really just about finding those commercial partners. I think we have a lot of great data, but to engage with that first commercial partner with our prototype, to be able to prove it with an external party is the biggest thing that we need to go to the next level. So we're looking for all sorts of different commercial partners to test. We have some of those pilots developed for the longer range system of the 250 kilowatt. And any commercial partners that are looking to test our system and potentially, find benefits from that early access. So we're looking for those partners right now.
Perfect. Thanks, Alex. Now
Thanks,
I'm going to, yeah, that's good. Just stay on, right? We'll probably have some a little bit discussion. Yeah. So off next is Mr. Dawson with Utility Global, right? It's another aspect of linking with hydrogen technology, but it's also then looking at transforming the storage component as well. And I think you guys are a little bit more advanced. You've already kind of gone through the corporate VC funding. I believe you're one of your corporate VCs is Saudi Aramco. So I'm going to pass the mic over to you, and then you can tell me where you guys are at, Matt.
Wonderful. Well, thank you, Amy. Share my screen. Hopefully it's coming through okay. But it's a pleasure to be here today and have an opportunity to share with you all about our vision for the future of the hydrogen industry. The way we see it, there's two main challenges with the hydrogen industry. And really the first is the cost. To really see wide-scale adoption beyond what we have today, we need to bring costs down. And the second is the CO2 footprint. And so, this talk will kind of share a little bit about our vision of looking forward and how H2Gen, our technology, is positioned to solve both of those issues. I wanted to start off, if my slide deck works here. Hopefully it's coming through. I wanted to start off and give a little bit of a history about our legacy. We're a spin out from Hall Labs, which dates back to the 1950s with Tracy Hall, who invented the man-made diamond. And ever since, we've been like a Bell Labs or an Edison Labs, lots and lots of innovation, commercializing breakthrough technologies. In recent years, we've sold 4 companies to Fortune 500 organizations for over $800 million just in the past decade. So a lot of successes. And when I was brought in to create utility, we had an ambition to develop a cost-effective, but also highly sustainable technology that could really propel the energy transition in the arenas of mobility and in industrial applications. And we explored everything from Pem electrolyzers to geothermal to batteries. And we discovered that high temperature electrolysis was an area that was really ripe for innovation and uniquely positioned for the future. So the challenge that we saw with traditional electrolysis is it's always been about the cost and availability of renewable electricity. In order to be competitive today, from our perspective, you need 24/7 clean renewable power at arguably less than 2 cents per kilowatt hour, right where you want to consume the hydrogen. And that's a big challenge. So we took a different route and we started to explore this breakthrough electrolysis process that's completely decoupled from the electrical grid. So rather than utilize expensive electricity, we utilize abundant waste streams that are all around to drive the electrolysis process. And when I think about, one of my favorite quotes is from Einstein. He said, everything should be as simple as possible and no simpler. And I think that's exactly what H2Gen is. It's the world's most elegant, most simple, most beautiful way to produce hydrogen. So you can see we can drive our technology off a variety of feedstocks, whether it's ammonia or whether it's biogas or steel waste. And we can actually have a negative carbon emission metric based on the CARB standard. So that's actually near and dear, to our heart. It's part of our DNA, the sustainability aspect of the company. And we just couldn't accept the true emissions profile of the incumbent technologies. If you run Pem electrolyzers off the grid today, it's actually about 2 times the emissions of doing an SMR and making it, liquefied and transporting it out. And if you look 30 years out at the projections, the grid composition is going to change, but not quick enough for that to make a big impact on the CO2 footprint. So from our perspective, by running on waste streams, whether it's biogas or steel waste or municipal waste, we can actually achieve this negative carbon intensity per the CARB standards, and we can have an impact on the environment today rather than hoping decades into the future to have a more significant impact. In addition to sustainability, the other main challenge with hydrogen is cost. And if you examine the underlying costs of delivering hydrogen, beyond just the cost of making it, there's costs of compressing, costs of purifying, costs of storing, and of course, costs of transporting. And these factors together and even individually many times exceed the cost of making the hydrogen. So we see a massive opportunity for making hydrogen on site and on demand as the customer needs, to the spec they need. So rather than having a one-size-fits-all product made at a centralized plant, we can come to a steel plant and they're going to utilize the hydrogen at low pressure. There's no reason for us to make it and produce it at 2000 PSI just to bring it back down to low pressure again to utilize it. We can go to certain customers such as electronics manufacturers where their purification standards are very different than other customers and deliver the specs that they need at an effective cost. And when you look at the cost of other types of distributed hydrogen, whether it's distributed PEM or small scale SMRs, a couple of things jump out to me on this plot. The first is, in order to keep the cost down, you really need to utilize your systems, and it can't be 6 hours a day. It can't really practically be 12 hours a day. You need to be utilizing your systems fully in order to be truly competitive with the incumbent technologies. The other thing that jumps out, of course, is just the raw cost of electricity, the cost of kilowatt hours per kilogram of electricity. And so you can simply multiply these numbers together. And if you're at 5 cents per kilowatt hour, your electricity price alone is going to cost $2.75 per kilogram, already becoming very challenged in the marketplace. And that's not even accounting for profit margins, not accounting for $2.5 million worth of CapEx for your system per ton, et cetera. So traditional electrolysis certainly, as we all know, has some challenges economically. And likewise, distributed SMR looks a little bit better, but as you go to a smaller scale, the costs of the capital equipment are quite challenging to overcome there as well. So breaking that $2 per kilogram barrier we see as a big challenge for some of the existing traditional technologies. Turning our attention to the market, today hydrogen is a huge market, 80 billion kilograms per year. But if you look at the growth trajectory, it's poised to be substantially bigger. This is a projection by Bloomberg that it might be up to 700 billion kilograms per year by 2050. And that shift is also very interesting to look at, going from many centralized applications where they're connected to SMR to distributed applications where they may not have an SMR plant on site, or they may not be connected to a pipeline. We see Utility Global playing perfectly to meet the needs of many of these growing and emerging sectors, from steel to power gen to heavy duty Class 8 vehicles, by being able to provide distributed hydrogen at low cost on site. So where are we today and where are we going? We're in the process of scaling our technology up with the aim to deliver our first commercial systems in the first half of 2022, and scaling by the end of 2022 up to 15 tons of production per year, and by 2023 being able to make 50 of these units. And you can see the image on the left is our first pilot system. On the far right, some of our reactor tubes, and then the manufacturing center where these are being made is shown in the center there. And what's neat about our technology, our core reactor substrates already have operated in 600 commercial systems with over 6 million hours of commercial operations and 35,000 hours of continuous operation at 99% uptime. So we have a proven platform for scalability, and the technology itself is positioned for reliable deployment. So our aim is to provide low-cost, low emissions, turnkey hydrogen solutions for customers looking to reduce their carbon footprint. And we make it simple for our customers with a simple business model. We pay for the equipment, and we provide customers with hydrogen gas as a service. And customers can realize environmental and economic savings immediately from day one. And part of what we're looking for here today and in the course of business is to find strategic partners that'll help us put additional demonstration systems in place in the coming year. So who we are, just kind of summarizing, we're a diverse group, 15, actually this, since this slide was made, we've grown even further, but 15 plus people with the aim of scaling to 20 to 25 by the end of the year. Some fun facts: we have 8 nationalities from 4 continents with offices in Houston and Dublin. We received $13 million so far in funding from a strong group of strategic investors that include multiple Fortune 500 companies and a large private equity firm that's focused on decarbonization. So I'd leave it with, if you'd like to be part of the energy transition, we'd welcome you as a partner to join us on this journey and do some initial deployments in 2022. We're specifically looking for partners focused on sustainability who have either sustainable feedstocks to run our systems or looking to be off-takers of clean, low-cost, sustainable hydrogen. And with that, I'll turn it back over to you, Amy.
Thank you. Sorry, I had to pop out there. My laptop crashed, but I am back. So I'm not going to turn on my video yet. And so next up is Dr. Carsten, right? I'm excited. He's going to talk a bit about Aeromine technologies, of course. Everyone's interested about wind power as well. And this is not the only technology. He is, I'll call you a serial inventor. So he's going to talk about this motionless wind turbine that he has been working on with Aeromine. So I pass the mic over to you, and then you can tell us more about Aeromine.
Thank you, Amy. I'm excited to be here, and I will share my screen here as well. As Amy said, I'm the inventor of Aeromine, which is a distributed wind energy technology. And so I will give you a little bit of background on that. I've been in utility scale wind most of my life. And wind is a very, very, very powerful energy source, renewable energy source. It's also the cleanest renewable energy source that are out there at scale. And obviously one of the challenges with solar is that it's not there all the time, especially at night. So bringing wind to the market really opens an opportunity to support the energy transition, especially if we can do it in the distributed area. So my vision is basically to take the power of big wind into the distributed area, on-site generation of buildings and so on, where solar has been extremely successful. And one of the reasons that solar is so successful is it's very scalable. And it's the same solution that goes everywhere, where wind is a little bit more customized, at least in the big utility scale. So taking that thinking and combining my knowledge of wind, putting those together has been really exciting. And I'll talk to you where we are as a company and where we're trying to go when we're really trying to bring these scalable systems in that can be impactful in the distributed energy space. And it's a big market. Distributed solar has really lit the way on this. In the US alone, there's tens of thousands of installations and really a large amount of energy that goes into the rooftops every year. And so the market and the need is established. So really we want to tap into that existing market. Let me talk to you a little bit about what the technology is and how the energy is created, because it's very different. It's not really a wind turbine. A more accurate description would be a pressure turbine. We have a set of flapped airfoils, which you can see in airplanes when they land, and spoilers in racing cars, etc. Flapped airfoils are extremely robust aerodynamically and also very powerful. They create a high lift force, which translates to a low pressure. When you place a pair of airfoils opposite to each other, that pressure gets even lower. And then we use what we call the center body to sort of collect that pressure and guide it into the center of the unit, in which where we have placed a turbine, a propeller, essentially, and an AC generator. And that essentially then drives the motor. So the wind comes passing through the airfoils. That is the swept area of the unit. There's no magic in that. We don't exceed best limits or anything like that. So the wind comes in there, the hollow body translate that pressure that comes from the airfoils into that center body. And since it's open at the bottom where the propeller is, now there's a pressure behind the propeller that sucks air through the unit. And that's what creates the power. What is neat about this is when you place it on a building, you can really take advantage of the speed up effects is from the building, because wind is pressured up over the edge of the building. So the edge of the building is where we like to be. The benefit of our design is that it doesn't move. There's no moving parts. There's no visual intrusions, and no environmental intrusions, and so forth. So this is completely still. You can't see anything moving because it's encapsulated. And the energy produced, depending on where you are, is somewhere between 300 and 1100 kilowatt hours per year per square foot rooftop used. And if you compare that to a rooftop full of solar, that's somewhere between 50 to 220 or so, going from Arizona to Alaska. So we have a smaller footprint compared to solar, and are more competitive in that aspect. And we can really bring down the cost of energy based on those characteristics. So the system is very impactful. We use very little part of the roof. You can see here some examples of installations along a warehouse, an office building, or a mid-rise building long. And that creates a big system, so it has an impact on the actual energy consumption. So, and you can see the backside of the roof is free, so we could also co-install with solar, and then really move towards a clean energy transition for buildings here, because now we're basically essentially doubling the power that you produce from your site. And that's sort of where we're targeting the larger flatter buildings, or the ones that has the rooftop space available, and where we can really make a big difference. Our track this year has been quite good. We are on track to install 2 pilot projects with a global chemical company, as well as a national real estate company. So 2 very different customers, and they all, it's the same drivers: sustainability mandates, energy transition, but also resilience of their buildings and the facilities. And the characteristic of these customers, besides having large buildings, is also they have a large portfolio of buildings. So our customer acquisition is well controlled, and we can have some template rollout of these systems. Again, scalability is the key to really success in this segment. Can we deliver? We have a team of utility scale wind energy expert that works on this in all aspects of rolling this out. And then we're tapping into our network with 4 key suppliers, a composite manufacturing company that's global, that is able to help us with the design for the manufacturing and get it into a process that can come out in a large volume. We have a world-leading fan company designing the motor and testing the propeller, preparing it for the pilots. We have an IoT company, so we can interconnect all the systems with our software, operating these systems into the cloud and get the data secure to the customers. And then we have a major electronics manufacturer lined up that are working in the area of the power electronics. And so we will have our proprietary power electronics that can deliver the AC power that comes out of the motor onto the grid. So a little summary of this is that it's a patented solution developed together with Texas Tech. It's a National Laboratories, formed Aeromine Technologies to create Aeromine and got us funded last year. We're on track to our commercial pilots, and we have a supply chain set up. So it's a very exciting time right now. We're raising a little bit of money to get into a longer runway in 2022 before we really can start taking off. And then in the background, we are also working on a marine hydrokinetic project, which is much longer term because it's utility scale power, and it's driven by an RPE grant with a small group of partners there as well. So thank you for your attention. Look forward to your questions.
Thank you. Thank you so much. And we'll see if I can still stay on without my computer dying. But I first want to start off with you, Dr. Carsten, because, you know, we talk about, you know, since you're my serial inventor here, right? Explain to some of the people who aren't just, you know, so familiar kind of about how long it takes, right? You know, from kind of your ideation when you come up with this, you kind of come up with your design and thought, you know, and then up to the point, you know, where you're at right now. How many years are we talking about here?
So I had a fantastic time having some years that I was teaching wind energy up in West Texas for graduate courses. And I had 4 years, wonderful years there, time to think about other things than my day job being in the utility scale wind space. And that really gave me the time to think about it. And that's kind of where we invented Aeromine. And then it's taken pretty much till, you know, a couple of years doing wind tunnel testing, doing computer models, validating, because it's a completely new concept. So there's really not much to benchmark up against, except the known components of each component, being airfoil, propellers, motors, wind, and what have you. You need to get those things together and figuring out how to pair all that stuff up. Right? That takes some years and takes some wind tunnel testing, fuel testing, and Cynthia and Texas State has been wonderful partners in that aspect.
Yeah. Thank you. I think that's great because I think it really shows you that, you know, you have to partner, right? Either from the universities, right? That also will kind of like co-develop with you, or, you know, work with you on getting the IP. If you're working with the university out, they're becoming much more advanced in that process, and as well as the DOE. Yeah.
It's very difficult to be lean developing hardware products. It's not a very easy task.
It is.
But especially in the early stage, this partnership with the university and national lab is really important.
Great. Mr. Dawson, with the utility, you're you know, you guys have got your CVC funding and all of this, right? I mean, where do you guys really, you know, kind of your next big challenge with utility global?
Yeah, for us, I think it's kind of twofold or threefold. You know, we're now beginning to really scale the organization, like I mentioned. You know, going to 20 or 30 people in the coming months. That's a great growth trajectory, but it comes with some growing pains, obviously. But from a challenge perspective, I'd say scaling up the manufacturing is probably one of our biggest challenges that's outstanding. We're really well positioned, as you saw. You know, to be able to achieve some of our targets, but you know, there's quite a bit of development needed to get there. So you know, it's one thing to do R&D, and you know, there's a host of challenges there. We've kind of overcome that, and there's a whole new set of challenges for developing robust manufacturing capabilities, supply chain, and really scale. And then, of course, driving to market is kind of a third element. Where, you know, I think we're really well positioned on that front, but obviously, you know, there's always challenges with getting commercial systems into the field.
Yeah, no, and I think this is what we see on a lot of the, you know, even hydrogen technologies, right? It's really not on the, you know, the core technology part. It's when you get to the part, and I think Alex, I'll pull you into this as well, because y'all are just a little bit earlier stage. Is in saying, okay, I really need to partner, right? Either from a component standpoint, you know, or another manufacturer, you know, how do I evaluate these companies, right? That's going to fit with what I'm doing. How do we rank them? You know, how do I then start to have these conversations with them? But then you're also then kind of worried about your IP as well. That's always that sensitive area. Yeah. And you know, which point you want to talk to, because this comes up, you know, when we have these conversations. So maybe you could share some of that, Alex, as you guys are beginning to kind of lay that out.
Yeah, I think you made me laugh on the IP protection, because it's always surprising how small of an industry it is. And so you do need to partner with those larger partners. And it's always a little bit of a dance to understand their true interest, if they're engaged with any other parties. But so It's about developing trusting relationships in that process. And so we're working through that on a variety of fronts, and it's definitely a challenge. And bringing on the right people is critical. You know, as your organization scales, you continually need to bring on new skill sets, whether it's the basic science you talked about, the chemistry and things like that, moving to mechanical engineering, moving to process engineering. So I think bringing on the right people with the right experience that have done it before to navigate some of those pitfalls is critical. So no surprise, but it's the team that makes it and helps you navigate that portion. So putting together a good team, a lot of people have great fundamental technology, and you got to surround yourself with the right people to get it to market.
Gotcha. I want to go back to Matt, because I think we have a lot of reluctant entrepreneurs, right, from our industry, right? And the people that, and we have conversations, when should I leave? When should I consider doing this? And you made a leap, right, from industry. Mm-hmm. And, this was not, your kind of first foray into entrepreneurship, right? Mm-hmm. So kind of what was that? What was your thought process as you're going through this and says, okay, that I'm just going to just jump away and I've got this technology bug. I have an idea. Let me go do that.
Yeah, there's always a lot of consideration. I think for me, it comes down to, what do you want to do with your life? What are your big objectives? And what type of environment do you want to work in? So I obviously started off my career in large organizations, multiple Fortune 500 companies or even, Fortune 10 companies. And, they have a lot of structure built in, and they have a lot of great policies and procedures. But obviously that overarching management makes things a little bit slower than it is in a smaller, nimble startup. And so, it really comes down to the person. I think everybody has to do a self-assessment of themselves and say, am I the type of person that can take big risks on and, is willing to accept, whatever comes of that, but also can, yield the big reward. And more importantly, is that fit my personality? So I think that's probably the most important, thing you need to reflect on as a person when you're thinking about entrepreneurship versus sitting in a large organization. What is it that your ambition is for life? Where do you want to have your impact? And are you, kind of bold enough and able to handle the ups and downs of the startup environment that you just, aren't, exposed to in some of these large organizations. So.
I think that's great advice. That we always talk about the failure rate so high, right? Very, very high failure rate, but you have to really have the stamina, right? Again, we keep on having this conversation. You have to pace yourself, right? You're going to have all these. Well, I'm going to ask, because I want to stick to the time. And that Dr. Carsten, do you have any thoughts? I mean, and just kind of feedback, because you've been doing this for a long time. Right. And you also, professor, very, distinguished in your field for it, what you see as the up and coming generation, with respect to entrepreneurship and the opportunities and any advice that you would give the audience.
I think your seminar's a very good one. And pay yourself for actually, I think are probably excellent advice. And I have enjoyed just like being in the utility scale in industry and grew with that. It was very entrepreneurial when I joined the industry. It was quite young. We're 250 kilowatt machines or something like that. So they were small by today's standards, and saw an immense growth. And that was a great learning curve. So to really get the company experience before you start working on your own inventions and own ideas and so on. So I do see a path there where you can really think about getting the experience that will allow you to become a successful entrepreneur and have many ideas, right? And hopefully you can be in a corporate company that also encourages that. And I've enjoyed that as well in my career. So that has been a big kickoff, and I would pass that along. So anybody, if it doesn't fit your speed, then find another place.
That's great. I'm gonna go back to Alex, right? On your P2H, right? For those, I know you're not funding right now, but you'll eventually be how are you guys looking at that in terms of, who would be your partners? Because there's a lot of different forms of financing these days, right? I think entrepreneurs are getting smarter. You know, they're wanting smarter capital. You know, they're, you know, these conversations, and I think this is good, right? They're saying, okay, listen, you know, I may see a VC is very interested in me, but I want more than capital, right? I really want someone that is going to put more skin in the game than just the money, right? So kind of how are you guys seeing that up in Ohio where you guys are located and in that kind of innovation ecosystem, and how are you kind of, you know, kind of that thought process you're going through as you focus on the next round?
Yeah, you make a good point. You know, funding is obviously valuable. You need it to continue to grow. But there's, you know, another element for any sort of validating capital. So there are now venture capitalists, private equity companies that are specifically focusing on these renewable areas, whether it's hydrogen or other spaces. And getting a company or an organization that has evaluated these, has already done deep technical due diligence and has legitimacy in the industry, can really facilitate future fundraisers for other partners can trust them in their diligence. So getting a partner that's respected in the hydrogen or just whatever space you're in, I think can be really valuable. Then obviously the strategic investors are critically important, and finding ways to get them the data that they want. You know, they can move slowly sometimes. And so being able to understand what are their key metrics and what might make them move faster, whether you need to create a competitive environment with a few different strategic investors involved. But I think there's strategic investors for getting that technical validator status, I think is extremely important. And also just opens up the market for where you want to go. So I think those different levels for validation as well as the commercial opportunity is extremely important to pair with any sort of financing you're getting. And that's what we look at when we evaluate different investment opportunities.
Great. Thank you very much. Well, I'm going to say a big thank you to all three of you. I know you're very, very busy. And I know that you guys will be glad to answer questions for people. So they can feel free to connect with Alex, Matt, and Dr. Carsten. And if not, you can always reach out to Ty Houston or Unique Ventures. But I think these are really, you know, really good companies. And I look forward to see kind of what happens over the next 3 to 6 months with you guys.
Thanks for having us.
Thank you. I'll pass it back to you, Balaji.
Looks like, oh, you're back, Amy?
Yeah, I am back. Yeah.
Okay. Well, it was a wonderful session here, Amy. Thank you very much. Thank you to the Ty Houston team, Ty Dallas team. Wonderful set of panel discussions. The showcase for the companies was absolutely excellent. And I think Amy could pull out a lot of companies that are on the forefront of sustainability and sort of highlight what the TSS Summit was about. I really appreciate her time in this, and I'm sure she has a lot of good nuggets in her portfolio. Maybe we'll have a chance to see those again at some point. But really, gentlemen, ladies, thank you. Thank you once again. I wish you from our side a good night and from your side a good morning. And thank you very much.